Hey Kevin, you can go ahead and unmute and get started.
Well, hello. Welcome to the webcast. My name's Kevin Ripa, and for roughly the next hour or so, we're going to be walking through some steps that we can use when we need to access data in the cloud. Of course, the cloud is, the big thing, especially now with the worldwide crisis that's going on. There's never been a greater adoption of cloud delivery. And I think that we are going to see an explosion in cloud storage, cloud data, cloud accessing, cloud hosting in the near future going forward, because so many companies that maybe had been holding off on it before and weren't sure if they wanted to do it and does it work. Well, they kind of got forced into it because of COVID-19. And now many of them are in the cloud. And I think what we're going to see going forward is that, wow, this really did work. And, it's not a bad thing at all. And so more and more, we're going to see adoption of cloud-based storage. And we've got to, as forensicators, figure out how to get at that data and how to get it out of the cloud. Now, in general terms, many people, they have an idea of, well, the cloud it's out there somewhere. It's, we've heard the cliches, it's somebody else's computer. So there's somebody else's computer somewhere out there, and our data sits on there. And we log in somehow, we do something, and there's the data we need. But when it comes to forensics, how do we get at that data? Can we image it in a forensically sound manner? How do we do that? How do we know we've got everything? How do we deal with potentially deleted information? How many different kinds of the cloud are there? So we're going to talk about a few of those tonight. So this is just a little bit about me. I own probably one of the oldest, if not the oldest, private sector digital forensics company in Canada. And we're the only ones in Canada that I'm aware of that have a Class 100 clean room. We do data recovery here as well. So we, if we get drives in that are damaged or something like that, we can rebuild the drives, change heads, recover them from burnt DVRs in fires, things like this, and recover data. We're also one of a very small handful of agencies in North America that engages in criminal defense work. So law enforcement often likes to look down their nose at us, but we always say that, that when it comes to digital forensics, the data doesn't lie. I can't make it something that it's not. So if everybody's done what they were supposed to do, then, my job's going to be over really quick and nobody's got anything to worry about. I'm also a SANS certified instructor, and I teach Security 301, Security 401, Forensics 500, and I'm also the co-author of Forensics 498. That's Battlefield Forensics and Data Acquisition, one of the newer courses at SANS. And we just got a notice as of 4 days ago about that our class now holds a certification. So our class will now prepare you for the GAC Battlefield Forensics and Acquisition certification within SANS, and that certification is going to be available as of August 1st. But anybody that takes the class between now and then, or anybody that's taken the class already, there's going to be special something set up so that you can go after the certification if you're so inclined. If you want to know more about me, my CV is online at the address you see on the screen. And of course, this is being recorded, so it'll all be available later. So I'm going to be talking about a few things in the coming hour. And I just, a little bit of a disclaimer that, this stuff's accurate at the time of the presentation, et cetera, et cetera. It might change. So, what we call it a tail light guarantee. Once you can't see the tail lights anymore, you can't rely on anything. But for now, this stuff works. So this is kind of what we're going to follow in this talk. We're going to talk about a few different methods and a few different types of repositories and how to extract information from them. So the first one we're going to talk about is fresponse. Now, fresponse is a program that allows us to interface with networked computers, whether they be within our enterprise or somewhere out there, somewhere another computer. As long as you can get an fresponse agent on the computer, you can speak to that remote computer with the fresponse that you have installed locally. And there's a couple of different deployments of fresponse. One of them, probably the most common deployment, is a deployment that, well, if I send it out to a user within my network, or I'm using it on their computer because I want to pull files off of their computer, they're going to know that I'm there. It's obvious that the program is running and this agent is running. But there's also another edition that, incidentally, in the Forensics 498 class, we give out a 6-month trial to this edition. It's like a covert edition. In other words, the end user, or the person at the other end, does not know that this is running on their computer, and you'd have to be kind of an incident response kind of person to detect that the agent's running. So a couple of different deployments. And so what does it do for us? Well, once we install it, we can reach out to various computers within our network, and we can run all of our forensic tools on that remote computer from our computer, just as though that hard drive was connected locally to our computer. It gives us read-only access to the hard drives as well as the RAM. However, I will say that if you're going to capture RAM with fresponse, don't try to pull it through the wire to your computer. I see that mistake made frequently, and unfortunately, it always ends in failure. The problem being that it takes too much time to pull the data, the memory, across the wire, and understand the RAM is constantly changing. It's live and it's very volatile. And so as you're pulling it down, it's changing. And this is going to cause something called RAM smear. So ideally what you're going to do is you're going to capture the RAM, and you're going to save the RAM to a connected device, something that's connected to the remote machine, or somewhere on the network that's closer to that machine than you probably are. It can do acquisitions from pretty much anything that's connected to the environment. And we also have the ability to reach out through the cloud to whether it be Dropbox or Amazon, Azure, anything like that. On top of that, it gives us a encrypted connection, a lot of different imaging capabilities, probably one of the better remote imaging tools that exist, even though it's not an imaging tool. It merely gives us access to the computers that we want to image. Thomas Hart asks, are we going to be able to get a copy of the presentation slides? The slides themselves, I'm not sure. That's up to SANS. I know that the webinar is made available, and I do believe that they put the slides up there as well. So when we want to install fresponse, we can see the management console on this slide here. And once we connect it all, once we put in the passwords and our credentials to the environment, and it's a lot easier to deploy this if you've got admin privilege on the environment, and you connect whatever machines you need to have connected to do whatever you want. In this case, we've got a server connected, and once we have that server connected, now it's available to us just like any computer. And if you've ever done an acquisition, then this is not going to look foreign to you at all. So if you had taken, a local hard drive, connected it to a write blocker, and then attached it to your acquisition machine, it would look very much like this. You'd see the drive letters mounted, and you could acquire the volumes as you would like, or certain pieces of data, email if you're only collecting certain data. So ideally, fresponse is allowing you to reach out to the network, reach out through the network to the target machine, and then you can pull everything back. And again, just a caveat on the RAM, but once you've collected it, you can pull it back through the network into an E01 or whatever type of forensics container, your evidence container you're going to use. And the imaging software isn't F-Response, and I want to stress that. F-Response merely gives you the ability to run your forensic software, whatever you're using, NCase or FTK or X-Ways or whatever the imaging tool of choice is. That's what F-Response is allowing you to reach through and do. So then when we talk about the cloud, where is the cloud? And what is the cloud? Well, Amazon, the Amazon cloud people have heard of, and people have heard of Azure, and people have heard of OneDrive. But Dropbox is also the cloud. Box is the cloud. I have an online backup solution that backs up the data that I work with on my computer in real time. It's a service called Backblaze. And so full backups of my computer are in the cloud at Backblaze. Now, that would be another cloud repository. Maybe there's a NAS, network address storage, a QNAP or a Synology or a device like that sitting somewhere out there, whether it's within your own internal network or, quite frankly, it's somewhere across the internet that you can reach with a public IP. So these are just some ideas of the cloud. Now, don't forget about things like Google or your Google Drive, and as I said, Backblaze, anywhere where you've got backups, things like that, because these are all types of the cloud. So, and of course, the homegrown solutions are, as I said, your Synologies, your QNAPs, those network addressable storage devices that you may have within your network. So here's an example of some of the cloud storage places that exist and what you're going to need to access them. Now, you've got to understand that there's no magic bullet. Just because you're a forensicator and somebody sent you out to collect a whole bunch of data doesn't mean that you get to bypass stuff. Now, for those of you that have been doing forensics, do dead box forensics, for example, you already know that if you have a hard drive out of a computer and the user accounts on that computer all have login passwords, it doesn't matter to you as a forensicator, because when you image that drive, it's going to mount that drive. You're going to see right past the password, and you can get at the data and collect it and interact with it and analyze it, and you don't ever have to have the user's password. Not the same in the cloud. In the cloud, you are going to need credentials. If you don't have the credentials, then you're not going to be able to get into that cloud storage repository. So here we just have a bit of a list of some of the more common cloud services and what you'll need to get in and what they're called. So usernames and passwords obviously are pretty common. And how can we get at that data in the cloud? You can see F-Response shines across most of these. Cyberduck is a great tool for doing that. We're going to look at Cyberduck. And don't ever forget the web browser. And we're going to show you what that means shortly, because a lot of people are afraid to use the web browser, but they say, oh, that's not forensically sound. There must be some mystical, magical way. But I always say, if it's stupid and it works, it's not stupid. And if that's the only method you have, and you can justify why you did it that way, that's all that matters. I hear so often in forensics, all of these different things that people say, like, oh, if the hashes don't match, then you can't introduce the evidence. Or, oh, you can't do live acquisitions, it has to be right blocked. These are all myths that are created by, I don't even know who, I guess vendors or people who want things done a certain way. The bottom line is, if you can explain properly why you did what you did and it was the best way to approach that problem, then that's what you've got. That's what you've got to work with. So let's have a look first at Cyberduck. And by the way, Cyberduck is a free tool, free paid. You can try before you buy. And you download Cyberduck, and you can see that it gives you access to quite a number of different repositories here. So you would just click on open connection and tell it what you want to connect to, whether it be Backblaze or Azure or Amazon or Dropbox, whatever it is. And once you pick that, it's going to give you the credential screen. So you're going to put in whatever you're going to put in. In this case, we're accessing Amazon. And so we put in our server names, we put in our access key, as well as our password. Once we have those entered, we just hit connect. And if we put them in properly, you are now connected to that instance in AWS. And of course, you can see the contents in there. Now, if you only needed one file, you're doing data collection or something, you know, you're targeting certain files, just simply right click on the file that you need and download to, and it will ask where you want to download it to, and then the download will start and it comes onto the system. Now, of course, once it gets onto the system, you probably want to hash it so that you can keep evidentiary integrity of the file going forward. Now, that's one way of accessing it, and that's kind of, I guess we could say, the GUI method of doing it. But we can also get there using the command line interface. Now, before I go any further, I just want to remind everybody that, of course, everybody who's ever done anything with SANS in the past knows that SANS lives and dies by its evals, and this is no different. So there's evals on this presentation, and the link is in your chat box. So sometime during the presentation or at the end, please take a moment and fill out the evals. I see a comment and another question. You're stupid if you don't use all the tools available. Well, yes and no. I mean, you're going to use whatever tools you have available to you. And we don't have, I don't think anybody has all of the tools. And even if you have all of the tools, you know what? Murphy is always going to ride on your back, and there's going to be times you're going to get somewhere and something is not going to work. You know, we talk about this whole forensically sound thing and the hashes matching, and Cynthia has asked, what does hash mean? Well, a hash is a mathematical algorithm that's applied to a set of data, a file or a hard drive or whatever. And when you apply this mathematical algorithm to the data set, it outputs what we call a hash value. Now, there's different types of hash. There's ND5 hash, there's SHA-1, SHA-2, families of hashes. And the difference between them basically is the math. Each of them has different key lengths that you can select. And so essentially, whatever data you put in, if I wanted to hash Kevin Ripa, it's going to spit out a fixed length output of that term. If I hashed the entire Encyclopedia Britannica, I'm dating myself now, young folks won't even know what that is, but it's a whole bunch of big books. It will also output the same length of hash. And a hash is, if you were to look at a hash as it's printed out, it's hexadecimal characters. So you'll never see a character in a hash output higher than the letter F, for example. And the idea behind the hash is to give the file integrity. So if I have a file that I have hashed, and I'm going to use a very simple example, just because I don't want to recite a 32-bit or a 32-byte hash key. But so let's say that I hashed Kevin Ripa, and the hash came out to be 12345. No matter who hashes Kevin Ripa, it's going to come, as long as they're using the same hashing algorithm, it's going to come back to 12345. But if I change even one letter, if I make it Kevin Ripa and I put 2 A's on the end, the resulting hash is not even going to be close to looking the same as the hash that was created with Kevin Ripa with 1 A. So this is how we maintain evidentiary integrity on a data set. So when we do a forensic collection, we'll usually hash the data while we're collecting it. And then once it's done collecting, we're going to hash it again. If the hashes match, the verification hash or the acquisition hash and the verification hash match, we now know that that data has not changed in any little way at all. If the hash doesn't match, well, we've got some questions to answer. And so we need to be able to understand why the hashes didn't match. And pretty much all I'm going to say about that, just kind of to round out the hashing, is that there are instances where the hash isn't going to match. And so, for example, in AWS, like we are here, we've downloaded a file. Well, we didn't hash it while it was up in the cloud. We hashed it once we got it down. And now we know what the hash is on our machine. And if we pass that file around to anybody, when they hash it, they're going to get exactly the same hash, or they should. But again, if the hash doesn't match, can you explain why the hash didn't match? When you image a hard drive, there are a number of legitimate reasons why the hash is not going to match. I'm not going to get into them because this isn't an acquisition class specifically, but you need to be able to explain why they didn't match. The notion that, well, it's got to be write blocked to be forensically sound, or we can't interact with the device, just simply incorrect. Anybody that has done any cellular forensics knows that you cannot create a forensic image of a phone with the phone off. The phone has to be turned on and booted and connected to whatever software, Celebrite, Oxygen, X-ray, whatever, and you are interacting with a live machine. It's only once you pull the data off the machine that you hash it, and now you can maintain integrity on that data set. So here we have Amazon command line interface. And so this is basically the same thing we did with Cyberduck. It's just that this is at the command line. So we fire up PowerShell and we just AWS configure, and it's going to ask us again for that access key ID. It's going to ask us for a password. There's some other optional things that you can put in. If you're unsure of the commands that you can run, just simply throw a question mark on the end of it, or AWS help, and it's going to give you some of the characters and things that you can type in, commands to get the results that you need. So once we log in properly, we can do a lot of the same commands that we would use at the command line. We can use Linux commands, we can use Windows command line commands. And here we've run ls. It's just a simple list command, and it listed what's inside that container, in this case, a folder called SANS Forensics 498. And so we moved over to that folder, and we can run another ls, and we can see what's inside that folder. If we just, in this case, we typed ls in the folder name, and it showed us the contents of that folder. So we've done the directory listing. Now, one of the things that we have to be careful of is what we're typing when we want to download something or collect something, because at the command line in AWS, it is case specific. It's case sensitive. So if it needed to have a capital S and you typed a small s, well, that's not going to work. You're going to throw an error like you see the 404 error in the middle of the slide. If it worked fine, then you're just going to get a flashing cursor back, and you'll know that you got a successful download. So going back to us not knowing what we're doing, don't forget about that the help command that will tell us how to use the program. And I can sympathize greatly with people who haven't spent a lot of time at the command line, because they'll type help and there will be this whole long list of stuff, and you're sitting there looking at this stuff and you're going, what does that even mean? I don't know what that means. And it was frustrating for me many years ago when I was learning this, because people would try to help me and they'd say, Kevin, just type help or look in the man pages, the manual pages. And it was great for them. It's helpful to me now because I know what it says and I know what it's doing. I just don't know a specific command for the function I want to perform. So now I can type help and I can get the specific syntax that I need, but it does take a while. And you know what? It's not easy. If it was easy, everybody'd be doing it. So that's Amazon. Let's have a look at doing something in the cloud when we have no normal tools. When we have, say, you know what, I don't have any tools. I've got the browser. I don't have F-response, you know, that's a few $1,000s. How am I going to access the cloud? And again, we had Cyberduck, but let's face it, there could be many reasons why you need to go through the browser to get the data, and understand that you can. So if you open up the browser and you have the subject's username and password, you can log into their instance. In this case, we've got Dropbox up. And old school is just, you know, going into the folder that you need and selecting the stuff you need and downloading it. OneDrive, we could do the same thing. You see here a whole list of folders within OneDrive. We can select them, we can download them. The key is to make sure that as soon as you download them, you hash them so that you can say, okay, the moment I downloaded them, after that, I didn't do anything else with them. And you can hash it and see that nothing has changed. Of course, here's an example of Google Drive as well. Now, something I want to pass on is this whole notion of the subject of the investigation giving you their username and password. And I've done many, many cases where either they're being compelled by the court, or they're happy to oblige, or they grudgingly oblige, whatever the case may be. But here's a word to the wise for anybody that's doing something like this. Never, ever, ever let them give you their password. And you're saying, Kevin, you just told me you need a password to get it. Yes, you don't want their password. Why? Because they're like most people. They use that same password everywhere. And now 2 weeks later, if something goes bad for them, they're going to blame it on you because you had their password. You don't need that kind of grief. So to save yourself that type of torment, here's what you do. At the point that you have legal access, whether it be through this or any other tool, to access their cloud information, you are going to tell them, log into your account, go to your security settings. I want you to change your password to Zimmerman, and let me know once you've done that. Once they've done that, you log in, you use the password you told them to use, and you download all of this content, whatever it is you need. Once you're done, you go back to them and you tell them, okay, change your password back or change it to whatever. That way, you can never be blamed for accessing other stuff that is theirs. Now, what about email? The email is stored in so many different ways, in so many different places. How do we look at going after the email? Well, Thunderbird Portable is a fantastic tool to allow us to do this, but there's a couple of little pitfalls in using it that we have to be aware of. So we download Thunderbird Portable, and you can put this on a thumb drive. You can put this wherever on the system you want to put it. And so then you go to install it, and once you give it a directory to install in, it's very lightweight, and now you can go through the setup. You go to set up an existing email account, and you put in the user's email account and their password. You're going to have to pick what type of mail folder it is. Probably, you know, far more people are using IMAP now than POP. These are just different email protocols. To give you an idea of the difference, POP is what we used to use back in the olden days when dinosaurs roamed the internet. And the way that that worked was somebody sent you an email, it came to the inbox of your email server. Once you did a send and receive in your email program, that email was downloaded to your computer and it was taken off of the server. Unless you knew more than the average bear and you knew how to log in and tell the server to keep a copy on the server, but most people didn't. Well, That wouldn't work today where we have email accounts on everything. We've got an email account on our phone and our laptop and our desktop and who knows what else, our iPad and all of our different devices, because we're always connected. So if we were using POP today, when I check the email on my phone, it would take it off the server and put it on my phone. Well, now what if I need that email on my computer? I guess I could just keep forwarding that email around, but it's just easier to use IMAP. And IMAP is the protocol that keeps the email on the server for specific certain circumstances. So that every time you log into your email, no matter what device it is, whatever's in your inbox is going to be in the inbox on all of the devices, and it will stay in the inbox until you've done something with it. So as I say, most people are going to have IMAP set up. So you select IMAP, and once you've got all of the stuff in properly, you're going to see it mount that email. And you can see on the slide here, you can see where we have the account over here, and we've got inbox and all of the different folders here. And they will populate. It's not an instant thing when you're downloading it, of course. Once it's all shown here, you want to bring the mail down locally. However, you need to make sure that you go offline, because if you don't go offline, when it starts to sync the account, you are going to now be pulling down potentially new email that's coming in the inbox. And maybe legal process isn't allowing you to do that. So you've got to remember to do that. The last thing you want is maybe you do another case tomorrow, a different case, and you're using this program and you didn't take the account offline yesterday. Now today you start up the account to do another collection of a different account. It's going to commingle this data. It's going to pull that new email down. And so you have to be very, very careful about what you're touching when you're touching online data. So let's talk a little bit about Office 365. Office 365, we can go at it from a web interface through the browser, or we can also use PowerShell, and we should probably use a combination of both because different circumstances call for different things. So when we're doing it through our browser, here's some of the web addresses you would go to get certain information, whether it be your Office for Business Active Directory, if that's in the cloud, any licensing or administration. And when you go to any of these, they're going to ask you for the login credentials for that. Maybe you need audit logs. Maybe you need to generate PST files because PST files don't sit as PST files out in the wild. We have to generate them. So this is how we could do it through the browser. But as I said, we can also do it using PowerShell. And here's the commands that we could use in PowerShell to get some of the information that we would want if we want audit logs, if we want mailbox information. And by the way, the audit logs are definitely what you want in an incident response investigation, because if someone got hacked, one of the things that they have to account for is the amount of personal information that may have gotten exfiltrated. Now, in many cases, they don't know if anything's gotten exfiltrated. I just dealt with a ransomware case last week where we go on site and that's all they care about. How much PII, personally identifiable information, left our environment. Why? Because you have to pay a fine based on the amount of accounts that left the environment. And if you don't know how much left the environment, you have to assume that it all got out of the environment. Well, that'd be a pretty hefty fine to pay, and companies have actually been forced out of business because they declared bankruptcy because they couldn't afford the fines. And it wasn't that they lost all that personal information, it's that they didn't know if they'd lost. They had no visibility, so they had to assume that they lost it all, and the fines were so huge it put them out of business. Well, these audit logs within Office 365 keep track of virtually everything. Who logged into the account, who opened a document, when they opened the document, what did they do while they had the document open, did they forward it, did they move it, did they do anything like that? And the audit logging is a very, very granular record kept on every file that you have up in Office 365. So you can use these both before or after an investigation to maybe you're collecting information, or maybe you're just circling back to see what you may have missed now that you have more visibility and have looked at stuff. If you're using PowerShell, there's a lot of things you can do, but we've got a couple here that are really pretty cool. If there's an Exchange server out there and there's 5,000 account holders on that Exchange server, well, how do you pinpoint the data that you want? You can't just tell them, yeah, we need to take a forensic image of your mail server, because I mean that's massive. But so if we want to, we're going to target one person. We're going to target Kevin Ripa. So that's the syntax to go after new mailbox export request. We want a mailbox. We want Kevin Ripa's mailbox, and we want to output it to where? This file path, server folder, kevinripa.pst. We can filter it even more than that, because right now I've got the PST. I got to go through the whole PST. Man, who's got that kind of time? So maybe we change our command a little bit and we say, okay, new mailbox export request. I want to look at the Kevin Ripa mailbox, but I want to filter the data. I don't want everything. I only want emails where in the body of the email, it has the word Bitcoin. And it was received later than March 2nd, 2019. Go get all of that stuff and only that stuff and push it out to the file path that you see here. And you can filter on just about anything, the sender, receiver, the date ranges, subject, all of that great stuff. Thomas asks, can't forensics help to determine how much was lost, but not who? Well, it depends, Thomas, and that is a very, very common answer that you get in forensics. It depends. Forensics can help, but let's just, because you asked the question, let's look at this ransomware case that I worked. They needed to know, first of all, did we lose any information? And B, was any of that information customer records? And so when we looked at the system, all 3 servers had been encrypted, so we couldn't get anything off the servers. They had probably one of the worst security environments that I've ever seen, which is to say it was non-existent. And so when we were looking at the perimeter logs, we could see that 2 gigabytes of data had been exfiltrated within a small period of time. The problem is they didn't have the appropriate logging set up to itemize what had left the environment. So the best that we could do, and they were actually in a better position than most, because the only customer data that they had, it was a car dealership. And so the car dealership takes all of the paperwork from the customer once they buy the car, and they take all of that paper and they scan them into a big PDF file. So one customer, one PDF, and it sits on a server. Well, these PDFs have a specific size. And so what we did was, we know from experience that when the adversary is going to exfiltrate data, they're going to encrypt it, or sorry, they're going to compress it on your environment first before they exfiltrate it, so there's less data to move across the wire. So we did a test on this customer data, because pretty much every file held the same information. They were all about the same size. So we used 3 different compression utilities to compress them to see how much will these compress. And then we can use that to extrapolate and say, okay, the 2 gigabytes that left, in a worst case scenario, if all 2 gigabytes were customer information, this is how many records we would have lost. Worst case scenario. Now, to be fair, based on the activity that I saw on the machine and the malware that was running in the RAM, and kind of watching how the adversary had gotten into the network and then pivoted to another machine and was looking around to where they wanted to be, it would be my educated professional opinion that no PII left, because normally what this would be is just a reconnaissance pull. Let's go find some data that looks juicy and yank some to see if we even have enough privilege on the box to exfiltrate this data. But I can't say that for sure because I don't know what was exfiltrated. So we have to assume the worst. Before they exfiltrate, Cynthia, before they take it, exfiltrate, remove from the network. So somebody hacks into my machine, grabs some juicy folders, and takes them out of my machine back to their computer. So that's exfiltration. And yes, Thomas, it does drive you crazy. Nice pun. I like that. Google Takeout. Okay, so we are going to talk about this, and we're going to talk forensics about this, but I'm going to scare you a little bit too, in case you did not know this. Google Takeout is a function of Google and applies to every Google account that exists. So if you have a Gmail account, and pretty much everybody does, you can use Google Takeout. And you should. So whether it's after this talk tonight or tomorrow or whenever you get a chance, I strongly encourage you do this, but be sitting down. If you've never done this before, this is a scary affair. So once you're logged into the account, you can just Google Takeout. That's probably the easiest way. And it's going to take you to the Google Takeout function for that account. Now, in this Google Takeout function, Google Takeout is a method that Google provides for you to extract all of the data from that account. And you can pick and choose what you want. So you can see here blog posts, your bookmarks, your calendar, all of the Chrome data types, shopping lists, map views, all the YouTube videos you watched. Oh, did I happen? And the list is much longer than this. What you see on this slide is a very, very, very short list. The list is much longer than this. And one of the things on this list is your search history. You want to freak yourself out? Log into your Google account and go and see what you searched for years ago, because they still know. They've got all of that data. If you have a phone or something like that connected to the environment, connected to your Google, especially an Android, because it's got to be connected, Google collects location information from your device. No, I don't care if you have location information turned off. They collect it, and it's down to granularity like 10 square meters. I'll take this one step further. Law enforcement has the ability to subpoena Google for this information, to find out where you were, when you were. What if they don't know who they're after? That's okay. There is a mechanism in place. Let's say that somebody knocks off a gas station. Law enforcement can go to Google Maps, and they can draw an outline around the gas station, the perimeter of the gas station, so all 4 streets around the gas station, and they create a record of that, and they can send that to Google, and Google will tell them the ID of every single phone that was in that perimeter any time within the time frame that law enforcement asked for. So if law enforcement said between 8 o'clock and 9 o'clock last night, or 3 years ago last night, we want the identities of all of the devices that were in that area. Now, the first return Google's going to give back is going to Cynthia, I'll come back to that. One of the things that Google's going to do is they're going to say, we're not going to give you the personal information of all these people. We're going to give you a non-traceable ID of a device. And that way you can start to separate, okay, what activity and where did these people go afterwards? Give you an idea of if these people are people of interest, because were they inside the gas station? Were they not inside the gas station? Once law enforcement feels that they have the record that's important to them, they go back to Google, and Google can now tell them well, as much information as they have on that record. Most of the time it's going to tell you exactly who it was, but they'll also tell you, okay, for an hour after that, that ID for that device, well, this is all of the places it went. And you can plot this on Google Maps. You just follow them straight to their house. Google has everything. So Cynthia asks, will having airplane mode on shut this down? Well, yes, but no, but yes, but no, but yes. Airplane mode will stop it from broadcasting right now, but it is still collecting. It is still aware. It still knows where it is. And so it's still collecting the information, but that information is local on the device. The minute you turn airplane mode off, sucks it straight up to the mothership, and Google has it. So Google knows everywhere you were when airplane mode was on. And so that's why I get a kick out of them using this technology for COVID tracing and saying, oh yeah, we're just going to put an app on the phone. You know what? If I want to do something I shouldn't do, I'm just going to leave the phone at home. But that's just me. Anyway, so you go to Google Takeout and you tell it what all the parameters you want. So you select the data points you want. You just want the email, or you want browser activity, you want search terms. What do you want? How do you want it? I want it in a zip file. And then you tell it to create the archive. Once you tell it to do that, go away. Go find something to do, because this stuff is not going to happen quickly. The last Google Takeout I did was 11 gigabytes in size, and it took 4 days. 4 days. 4 days after I requested it, I got an email from Google that said, hey, your contents in Google Takeout are ready for download. You click on the link and it will take you to a page like what you see here, and it will show you the archive it's created, and you just click on download and it will download that to your machine. And it downloads everything, and the emails that it downloads are going to be in an mbox format, which is probably about the simplest format you can come across in email, and you can open mbox with just about anything. So Google Takeout, great tool to pull all kinds of Google information. Make sure that you're only grabbing what the warrant or the subpoena allows you to grab. If you overstep your bounds, you can find yourself in a heap of trouble. So that brings to question the legal process. What is it? Even if you have a proper subpoena, a proper court order, whatever it is, to get the data, can you still get the data? Because what is the data? If the data is encrypted at rest, big deal. Now you got a pile of encrypted data. Is it going to be usable at all? What format is it in? Even when you have that, do you have legal access to it? It's great that I've got a subpoena or a warrant to go after the people that stole my data, but they're in Russia, or they're in Ukraine, or they're in Redactistan. You're not going to get those people to give over those records. It's not going to happen. Now we get to the fun part. Everything is connected. Everything. So just in this small diagram, we've got printers, and we've got clients, endpoints, we've got servers and switches and routers and firewalls and lions and tigers, oh my. And everything, we're going through all of this stuff, and we need data. So you're accessing traffic all the time. You're accessing data all the time, and it's leaving records of everything that's happening. It's leaving a trail. So what do we want to do? Well, we want to grab that data from somewhere. If we're internal in our environment, we could hook into the switch, and we'll show you kind of what that looks like in a little bit. We can hook into a switch, and we can grab all of the traffic from a port on that switch. So if there's 10 computers connected to that switch, and we want all of the traffic from one of the computers, we can plug into that smart switch, and we can do port mirroring to make a copy of that data onto another device that we've plugged into the switch that we can take away to analyze later. Now, if it's going outside of the network, well, we can attach a device to the perimeter, to the firewall, and grab all of the data coming out of the environment. And Cynthia asks, what's a smart switch? Well, we know what a switch is. A smart switch is just a switch that has a span port as one of the holes on the switch. And this span port is a port that allows us to plug in another computer or network addressable storage so that we can log into the switch and we can tell it, all of the traffic that's going to this computer A, to Cynthia's computer, I want you to make a copy of all of that data and push it out to this device connected to this other port on the switch. So this is known as port mirroring. And so we can do port mirroring, or we can do network taps. What is the difference? Well, port mirroring is making an actual copy of the data and putting it somewhere else. So we have to be mindful of how much data we're creating, because if you have a 1 gig connection, a 1 gig pipe in your environment, and you normally see traffic of 600 megs, Well, you can't mirror it because that's now 1.2 gigs of data. You've got the normal data and the mirror of the data. So in most cases, what we'll use port mirroring, maybe on a local switch, low level, one computer. But there's times I've done it in incident response investigations where we have to grab all of the traffic going in and out of the environment for 10 days. You can't do that with port mirroring, so we use something called a network tap. And a network tap is basically, there's a number of ways of doing it, but a common way is you build a computer, you put a VM on it, and that virtual machine is going to be a copy of, usually Security Onion is a very popular one to use. And within Security Onion, we can run something like tcpdump or some other type of web capture tool, and it's going to just, it's going to mirror, or it's going to create all of the traffic that's going through it. It's going to grab a copy of it and copy it off to a separate hard drive in the computer so that it's not eating away at your bandwidth. And then we come back days later and we can analyze that traffic, and we'll coming up to see how we analyze that traffic. So what we're going to do is we want to collect this network traffic. So we're going to use a tap or a port span or a mirror, port spanning, port mirroring, same thing. To get the data, depending where in the infrastructure we're grabbing it from. And we're going to collect it either as a PCAP, packet capture, or as NetFlow data. And then we're going to push it into something so that we can analyze it. So here's an example of using tcpdump, and you can use dumpcap and tshark and as many, or dumpcap and some other packet capture tools. And tcpdump, very easy to use. tcpdump doesn't care what you're doing or why you're doing it. It just knows you want it to capture data. So you tell it what interface you want it to listen on and where you want it to push the traffic out to. And we get to see, we'll just tell the computer what we want to do. And we get to see here, it's going to push it out to that file. And once we have that file, we can use a tool called Wireshark that will ingest that file and pull it all apart for us. Now, I know that this looks scary, and that's only because it is. If you've never looked at this traffic in Wireshark before, it's terrifying, and it takes no time at all to generate traffic. In this slide, you can see it's got 32,000 packets of data. 32,000 packets of data could be 2 minutes. Doesn't have to be much data at all. It just depends on what the data is. And so what do we do with this information? Well, a good place to start once we've collected the PCAP and we put it into Wireshark is to look at the statistics tab to get an idea of the kinds of traffic. Now, this is everything. This is every 1 and 0 that went across the wire. There's nothing missing from here. So we've got to filter it down because, as you can imagine, there's going to be a lot of data there that's absolutely useless to us. So when we do the statistics drop down, it gives us an idea of the traffic that we have available to us, and then we can start filtering it. So for example, in this filter, we're telling it, I only want to see IP traffic, so traffic with an IP address, only of IP address 192.168.91.1, and only traffic from TCP port 7680. So now you're getting very, very, very specific as to the traffic you want. Now in the PCAP file, it's broken down. The PCAP file consists of data that we've extracted, and that data could be FTP data or email or whatever data is coming across the wire. So Wireshark is a great tool to use for that. But what if we don't like the look of Wireshark? Wireshark is a scary thing, and maybe we don't need all of that data. I'm curious about internet traffic. We're going to find out why we're interested in specifically internet traffic in just a minute. So Daniel asked a question, do you recommend using capture filters in the acquisition step? Certainly with tcpdump, you can tell tcpdump or dumpcap what you want to capture. I only want to capture web traffic. I only want to capture mail traffic. Yes, you can tell it right down to the port number what you want to capture to cut down on the volume of traffic. So absolutely, as granular as you want to be. Now, using a tool called NetworkMiner, it already takes that PCAP and crunches and chews on it for us. And it will spit stuff out based on IP address. And if we want more visibility into certain visits from an IP address that we connected to, it will break it down. And we can even get to see all of the artifacts that created the web page that was collected that caused that traffic. And then we can do other things with it. We can click on the messages tab once we have something highlighted. If it was email or a message, it will show us the contents of that traffic. Remember, all of the traffic is in that PCAP. It's just a question of finding something that knows how to read it. And then we can sort it differently. NetworkMiner keeps all of the traffic separated by IP address, as I had said. So you get to drill down by IP address. And here there's not a whole lot of exciting stuff. We're seeing some certificates, site certificates. But depending what's in there, if there was somebody did a download and then deleted it, you're going to find it in there. So this gives you an idea of where that device is communicating with. And why does that become important? Because the last topic we're going to cover, Internet of Things. Now, people say, and we do this in the 498 class, what happens if there's a camera on the wall, or a Nest thermostat, or a doorknob, or a toaster, or a connected fridge, or whatever, and you want to know, okay, I need to know who owns, I'll just throw out a simple, a drug case. So you've got a drug case and you don't know who owns the house. You don't, the owner of the house says, hey, I just rent it to these people, but you don't know who these people are. If you can run tcpdump within the network, you can capture the traffic of this security camera beaconing out to the vendor. So if it's a SWAN camera, it will beacon out to SWAN, and it's beaconing out its information. Why? Because somebody's at the other end of that. And somebody has a phone in their hand where they can look at the camera. Well, how does that magic happen? Through the use of DDNS. And DDNS is it's a little thing that the provider like SWAN will set up so that it will provide you access to your cameras. And you don't have to do all of that complicated networking stuff. So the camera calls out to SWAN, SWAN calls out to your phone. Well, if you as the examiner are collecting this traffic, you now know that it's SWAN you need to go to with a subpoena or a warrant to find out, okay, this traffic at this date and time from this IP address to you guys, where did you forward it on to? We need that information. And now somebody can't say, well, that wasn't me. Really? Let me see your phone, because now I'm looking at this camera. And then we've got Angry IP Scanner, another great program, and we can run this from within an environment. This is a great tool to use to find stuff that we may not normally be able to see. So if somebody's got shadow IT within the environment, they've got a hidden router or something so that they don't have to connect to the company's network, you're going to see it running a scan with Angry IP Scanner. And you can scan IP ranges, you can scan port numbers, and when you find something and you want to know what it is, you can just right-click on it and you can say Open Computer, and then tell it to open it in a web browser. Now, in this case, that IP address led back to Pi-hole, which is a program that we use to black hole internet ads and things like that. Now, we were talking about this DDNS. Well, Wireshark will give us DNS information, and we can tell it, I only want to see DNS traffic. Now, here is all Google stuff, but if this thing's calling back, if it's Alexa, you might see it in there, but it may call back to, as I said, SWAN, the security camera. You would see that in there, and now you know who to go to with a subpoena or whatever. You can slice and dice this into conversations. If you've got one small packet of data and you want the whole download or that whole communication, that whole web page, all you have to do is right-click and tell it to follow the stream. If you just want to see the HTTP traffic, so you want to see the GET request or what are the contents of the page that was being looked at, point it to HTTP. You're going to see this. Obviously, if it was encrypted, you're not going to see it. Now, that is the quick and dirty. There's so much more. Basically, what we went through was pretty much an entire day in the Forensics 498 class, and we do a bunch of labs and people get to play with stuff, and you get to collect PCAPs and you get to take pre-cooked PCAPs, and there's even a PCAP there where you mount it and you pull a whole video out of that PCAP traffic and rebuild the video and watch it. I'm not going to tell you what the video is, but it's pretty darn cool. So we have all of these methods of collecting data in the cloud. It's just a question of what do we need to do to fulfill the role we're trying to play. And as I said early on, if it's stupid and it works, it's not stupid. Thomas said, I'm going to use whatever tools I've got. And you know, the biggest takeaway of that is you shouldn't have just one tool in your toolbox. In this slide, outside of F response, everything else is free. So, you know, you've got a lot of alternatives to work with. I'm done. And so I want to thank you all very much for coming and hanging out with me and listening to what I had to say. Please, please, please take a moment to fill out the evals on your way out the door. My contact information is on this slide. So, you know, if you don't want to download the slides or watch the video again, take a picture of this slide. I'm always available. I recommend that if you ever want to reach out to me, you got questions or something like that, by all means, shoot me an email. You can try to phone me, but I don't often answer the phone. Well, it's COVID time, so I answer the phone now, but usually I'm on an airplane, so I can't answer it. Email is always the best way to get a hold of me. You can follow me on Twitter, and I'm also responsible for something called my SANS 3 Minutes Max. So I don't know how many of you have heard of that, if any of you have heard of it, but you know, everybody's doing these 1-hour talks right now, these lunch and learns and stuff like that, including SANS, quite frankly. And I'm the guy that says, I don't have an hour. And I'm sick and tired of watching these hour-long things, and I sit there and 40 minutes into it, I find out this wasn't anything like they said it was, and I've just wasted 40 minutes. Now, that'll never happen at SANS. I mean, this is all wonderful information, but I started 3 Minutes Max, and it's every day of the week, a 3-minute video on something forensic related. It might be explaining the wonderfulness of shell bags and how to extract information out of jump lists or link files, or just all different kinds of digital forensics and incident response goodness in 3-minute chunks. So even if it's no good and you didn't like it, well, it was only 3 minutes, it didn't kill you. So I have nothing else. You've got my contact information. Thank you once again for coming, and hope you all have a great evening.